Thanks again, everyone, for coming out to our virtual annual meeting. Hopefully we aren't virtual for too much longer, but we are thankful to have you guys here today. We're thankful for all of the sponsors who have kind of made this possible. It's been an effort to get it going, and we're really excited that it's finally here and we can finally start getting some of these great sessions rolled out. I want to take a minute and thank our session sponsor, Urban Systems, for their support and for generously sponsoring our very first technical session of the virtual annual meeting. For their sponsorship, we've got a quick video from the folks at Urban Systems, and then we'll get right into introducing our speakers. So we're going to pull that video up right quick, and then we'll jump right in.
Urban Systems is happy to be sponsoring the 2021 Southern District Annual Meeting.
Hopefully this will be the last virtual meeting and we'll be together soon.
Awesome. Thank you for that, Sarah. All right. So our first presenters today are Dr. Joe Hummer and Dr. Amir Molan. They're going to be sharing with us a presentation about the comparison of signalized intersection designs with 3 critical phases. Dr. Hummer, if you want to go ahead and get your presentation teed up while I get our introductions through. Dr. Joe Hummer is the State Traffic Management Engineer with the North Carolina Department of Transportation's Mobility and Safety Division. Joe is a recovering academic who spent many years on the faculty at UNC Charlotte, NC State, and Wayne State before joining NCDOT in 2016. He specializes in alternative intersection and interchange designs. Joe began wondering why median U-turns worked so well as a child growing up in Detroit. He began researching alternative designs in 1990 and has published numerous articles about them and has invented several new designs himself. Joe is currently the president of the North Carolina section of ITE. Joe is joined today by Dr. Amir Molan, who is a lecturer at Cal Poly San Luis Obispo. Fun fact, Amir is joining us from Iran today, so it's his bedtime, so everyone be super appreciative and thankful for the time that he is here with us. Amir worked at Wayne State University, Michigan State, and the University of Wyoming before moving to California Polytechnic State. To date, he has been the first author and co-author of over 35 peer-reviewed scientific articles in civil engineering journals and conferences. One of Amir's recent articles has been selected as the 2018 Best Paper in the ASCE Journal of Transportation Engineering. He is an active researcher in the field of traffic operations analysis, alternative intersections, highway safety, traffic simulation modeling, and pedestrian and bicycle safety. Particularly, Amir is interested in evaluating new designs for improving the performance of existing interchanges and intersections to provide a better service for all transportation users. So with that, Amir, Dr. Hummer, go ahead and take it away for us.
Okay, hello everyone. So my name is Amir Molan. I'm a lecturer at Cal Poly San Luis Obispo. I'm so happy to have this opportunity this morning and this afternoon actually in North Carolina to present a few slides of the presentation related to 3-phase intersection designs that I have the honor to collaborate with Dr. Joe Hummer from North Carolina DOT. So this presentation will cover some ideas related to converting 4-phase intersection designs using 3-phase intersection design. So based on previous studies, we know that 2-phase intersection signals perform very well. So for example, reduced conflict intersections, RCIs, also known as ARCA, J10 superstreets, they are performing very well. We got very satisfying performance. In North Carolina, I know that we have more than 100 of them, and both in terms of safety, in terms of traffic operation, specifically in terms of progression system, we got very satisfying results from them. Also median U-turns, which is very popular in Michigan, is also another one, and also CFIs, continuous flow intersections, that probably and they offer the highest capacity among all intersection designs. So, and of course, we know that sometimes maybe it's going to be a big challenge for us to use this kind of two-phase intersections. What's the reason of that? Because it's gonna be a big change, and sometimes maybe neighbors, business owners, politicians, media are not satisfied with that. Anyway, removing 2 out of 4 spaces, that's a big change. So especially in some cases, such as when we are dealing with high demand on minor streets, that's going to be a bigger challenge. That probably there's gonna be significant cost, there's gonna be significant impacts that maybe they are not going to be the best options for us. So in this situation, please the next slide. So in this situation, maybe we can provide a better situation by considering three-phase design. So instead of maybe removing 2 of these spaces, we can remove just 1 of them, and to get some results similar to two-phase results, some benefits that we can expect from two-phase intersection design, but just by removing 1 of them. Also, it makes sense that when we are just removing 1 of the phases, so we can provide more direct movements, especially in some designs such as super street designs, such as RCOT, RCIs, and it's going to be maybe a big factor for us, a big advantage for us, if we can maybe provide a direct left turn from minor streets when we are dealing with high left turn traffic demands, instead of maybe asking left turn people to use the adjacent U-turns that increase the travel distance, sometimes such as 1,000 feet or 1,200 feet. So for the same reason, consequently, we can expect less cost, we can expect less impacts, and in a nutshell, we can convince public, we can convince people easier to accept this kind of new alternative designs. So the next slide, please. So in addition, we can expect good progression system in some cases. For example, in this situation, in this figure that you are observing the time-space diagram of one existing intersection on US 29. So you see on the, of course, please pay attention that on the horizontal axle, we are seeing the spacing between intersections, and also on the vertical axle, we are seeing the time. For example, here, in this case, we have a 170 seconds for the cycle length, and almost we can say 85 seconds of that is for green, and 85 seconds of that for the red interval. So in this situation, we see that by considering three-phase designs, it's going to be a better progression system, because we are dealing with 33 seconds, 29 seconds for the eastbound, westbound for the directions here, as you can see in the figure. And by providing 2 more phases, it's not going to be probably a good progression system. However, just having 1 more phase, having a 3-phase signal, and here is going to be it's gonna be a good performance in terms of progression system as well. So from now, I appreciate if Dr. Hammer, you could.
Okay, thanks, Amir. Following up on what Amir was saying about signal spacing, this chart shows a just basically worked out version of a standard equation that's in all the textbooks. And, you know, especially looking at the alternate progression columns there, this is for a 120-second cycle, which is more or less corresponding to a 3-phase cycle. You can see there's actually some good signal spacings there that fit. So depending on what speed you want to progress along the major street, to get good two-way progression with 3-phase signals can sometimes be convenient. You know, for instance, if you have signals spaced at 3,000 feet apart and you want to progress at a speed of 40 miles an hour, a 3-phase solution with a 120-second cycle will actually fit very well. For that matter, 35-mile-an-hour speed as well. So, sometimes three-phase signal can be good in the sort of intermediary, as the previous slide showed, and then sometimes three-phase signal can be good just in itself, spacing between signals based on the speed and that spacing as well. So, we think there's a role here. This presentation, we're going to run through quickly some of the three-phase designs that are out there for four approach intersections, some pluses and minuses of each of those designs. And, always with my work and Amir's work, what we're trying to do is inspire you to kick the tires a little bit. Next time a file lands on your desk and you get a chance to try some intersection alternatives, maybe you'll think of these as well. Give them a try. You probably, maybe they'll work out. If you end up going back to a conventional four-phase, fantastic, but at least give a try to some of these. A few notes before we get into the designs themselves. Well, here's a list of the 10 that we'll show you during this presentation. The 3 on the left side are fairly common across the U.S., offset intersections, partial CFIs, and quadrant. And then the list on the right side of the slide are the uncommon ones that have maybe been built a few places or have just really been published but not built yet. We did not include the New Jersey jug handle in our list. In North Carolina, anyway, we do not consider this a competitive design. Basically, it takes up more right-of-way than a partial CFI and only delivers a fraction of the capacity and the lay savings. So if you're in New Jersey, sorry about that, but that's where we drew the line. Here's a note about the capacity numbers that we're going to show later. A little bit of nomenclature here. Basically, the key thing here is these are critical lane analyses, vehicles per hour per lane, sort of meeting in the middle of the intersection. And the assumption we made here is that the major street left volume equals the minor street left volume equals the minor street through volume equals a variable we call L. And so if you run out the critical lane volume or the critical sum at a conventional intersection, the answer is 3L plus the through traffic, major street through traffic divided by 2 lanes. The major street through is the same term in every solution, so we sort of drop that out, and we'll just report capacity on the basis of how many L's are there as you work through the critical lane volume. And of course, the lower the better would be the answer for capacity here. So that's what our nomenclature looks like. One more note on our method. As far as pedestrian crossings go, we rated each of the designs based on the number of flags it achieved with the NCHRP report 948, the so-called 20 flags method. So yellow flags are inconvenience, and a red flag is a safety concern. We just looked at the total number of flags as a pedestrian would try to cross each of the 4 crosswalks at an intersection. And we really like the NCHRP 948 method, recommended to everybody who's interested in pedestrian and bicycle crossing quality at any intersection. Okay, so on to the results. And here's sort of setting the table, a conventional 4-approach intersection. And what you can see there is some, oops, I think I just did something. You lost my screen, didn't you? I lost my screen anyway. Show screen.
We
can
got
see
it
the
back,
screen.
Joe.
Can you see the screen? Okay.
Yeah.
Oh, great. There it is. Okay, I got it back. So what you see here is conventional intersection. The it's a mixed bag, right? Capacity is low. That's colored red, but vehicles don't travel any extra distance. There's no extra right of way to obtain, and pedestrians are sort of blah in the middle. That's colored yellow there. So a mixed bag for conventional. Notably, though a capacity that does not work very well. Next up, here's a three-phase design, offset intersection, right? Capacity just so-so, extra travel distance, not good, lots of extra travel distance at an offset intersection. But conflict points, which are a measure of safety, really good with this design. They should be safe. They do require some extra right-of-way, and again, pedestrians sort of blah in the middle there for that measure. Partial CFI with terrific capacity, and nobody has to travel any extra travel distance. So those are both superb. But on the other hand, conflict points coming in at 30, which is not great, does require lots of extra right-of-way for those two ramp areas, and it's pretty much the worst design as measured by the 20 flag method as far as getting pedestrians across the street. So again, a trade-off here with great capacity, but not so good on a couple other measures. And finally, among the more common three-phase designs, the quadrant roadway intersection with some terrific capacity, again, as low as it gets, but lots of extra travel distance, conflict points not good, lots of extra right-of-way for that connector road. But the pedestrians got good again. So this is the pattern. This is what we're really presenting here with you today, are these trade-offs. There is no perfect design. Some of these three-phase designs better in some aspects than others. But here's where we hope, for your particular project, with your particular concerns, you can work that trade-off and pick the best design that's out there. Now to some of the less common ones. This is a CFI MUT, median U-turn combination that we're actually, looks like we're going to build a couple of these in North Carolina in the next few years with great capacity, travel distance, pretty good, just asking one movement to travel extra distance. Conflict points, right of way, not so good, but treats pedestrians pretty well. So really 3 out of the 5 aspects working pretty well for the CFI median U-turn combination. Next, let's look at the so-called partial median U-turn. As far as we know, there's only one of these that's been built in the world. It's in Idaho, but maybe they chose pretty well. 2 greens and 3 yellows as you look down the different impacts here. Great for capacity and pedestrians, and middling for the other measures that we looked at. Maybe partial median U-turn, we should build more of them than just the one. Here's a design that's sort of the flip side of the partial median U-turn, redirecting the minor street lefts and leaving the major street lefts to be direct. Not so good on capacity here, middling on the other measures, but really good on pedestrians. I guess you'd say, sort of why would you ever do that one when for the same cost, the same impact, you could have the partial median U-turn instead. Here is a design that redirects the basically one of the side streets. So that's in this diagram, that's the northbound movement. Everybody gets to turn right, just like they're at an RCI. So low capacity, not great, but a couple of green shaded impacts, a couple of yellow ones there. So yeah, okay. Here's the through cut. This one is becoming popular with our neighbors to the north in Virginia. I actually lifted this picture from the Virginia DOT. With terrific capacity, again, green shaded as good as it gets. 3 yellow impacts there. And the weakest point, as far as we could tell for a through cut, is the pedestrian treatment. With 30 flags, it's not great. Maybe there's some things we could do to help the cause there. But on first glance, pretty good with everything else other than pedestrians. Reverse RCI, we have 3 or 4 of these in the ground in North Carolina, but it didn't compete that well as far as the measures we looked at here, and maybe we shouldn't build too many more of these. Not good capacity, asking a lot of extra travel distance there. Does good for conflict points, so it should be safe, relatively speaking, and okay for pedestrians, but also has some extra right-of-way. So yeah, maybe we could do better than the reverse RCI that you see in the picture there. 7-phase signal. I think this is the last one we got to present. We published this a couple of years ago in ITE Journal in 2019. And again, you can see a mixed bag there. Travel distance and extra right-of-way scoring particularly well, but not so much on conflicts, and pretty rough on pedestrian crossing there too. So overall, what we tried to do here is to show the trade-offs between these 3-phase designs. I guess our results were a little bit disappointing to me in the sense that I was hoping for a clear winner. I wanted one that stuck out and said that this one looks generally like it'll always work or usually work at most places, but we didn't get that. We got a lot of trade-offs. We can't have it all, but if you're in the intersection design business, you knew that already. That's the life we live. We're constantly making trade-offs. We're making compromises. It's an imperfect world. The best intersections, as far as we could tell, are the 2-phase designs, RCIs, full CFIs, median U-turns. But like Amir said, if you can't do those, if you must compromise, then maybe you can work in a 3-phase design to still get that progression benefit like we talked about and get some of the better impacts like we saw down the list of the designs. At least 10 viable alternatives, and there's probably more hiding out there. And again, what our results really showed is a trade-off between the various impacts. Mostly you get higher capacity than conventional intersection, but then after that you end up trading off right-of-way versus pedestrian, etc. Here's the best of the blue ribbons, a list for capacity. There were a lot of designs that delivered the top capacity. Travel distance, you can see there, best for conflict points, right-of-way, and the best for pedestrians. Overall, maybe the best of the 10 that we looked at was the partial median U-turn. It had 2 greens and 3 yellows, and no pink or no red impacts there. So if you're looking for an overall winner, maybe that's the one that rose to the top of the heap. I think there's no substitute here for further research. I think hopefully you agree that we've shown enough promise with these designs that we can do more, and there is promise here. So let's get some in the ground. Let's get some built. Let's test them. Let's refine them. Let's start to standardize, and let's see if they really work like we think they will, and start to fill in the gaps with some empirical data. That would be terrific. So unless Amir's got something else to add, I want to thank you for your time, the chance to present our work, and open up for questions. There's our contact information, and Amir, like me, is a intersection and interchange person, so anytime you want to talk intersections, give us a call, give us an email. It's what we do. So thank you. Turn it back to Kristina.
Awesome. Thank you, Joe. Thank you, Amir. We had a couple of questions come in. One question was specifically asking about whether there's been any data to look at the existing through traffic and which one may or may not be better. I don't know if you guys want to take a stab at that.
Yeah, I will. Amir, jump in after me if you got something else. But for the existing through traffic on the major street, they should all be pretty similar. All the ones that have the same capacity level. So I think the second from last slide there listed the designs that had the highest capacity levels. At that level, you're at 3 phases, so you're going to get that much green time for the major street through. Not as much as a 2-phase design, but more green time than a 4-phase design. And then after that, you get that much capacity available for the major street through. So it's pretty much, I would say there's sort of levels here or shelves of these. different designs and how they fell. Yeah, good. Thank you.
Awesome.
Yeah, something just I want to add that also in the beginning of the simulation results that we got, so we consider that if we are going to have 3 phases, through traffic versus 2 phases, through traffic and through cut intersection design, and we noticed that if we consider 3 phases in terms of safety, probably we will get better results, because in the other situation, when we have 2-phase signal, it's going to be some conflicts between the minor streets, between the left turns and right turns. So that's also another concept that probably when we get more results in the end of the research, and we can expect a higher safety for the 3 phases versus 2 phases. Maybe in terms of traffic operation, there would be some benefits for 2-phase signal, but in terms of safety, probably 3-phase signal for through cut would be better.
Awesome. And then one more question, and then we'll move on to Joe Milazzo's presentation. Someone has asked if U-turn crossovers or any intersection with added travel distance creates impatience in drivers and lead to additional negligence in their driving habits.
That's an interesting way to phrase it. Increasing negligence. What we know is that we do not get increased crashes. So if the drivers are being negligent, it's not showing up in the crash data. Perhaps they are being negligent. It's maybe frustrating, maybe some other emotions, but it's not showing up in the crash data consistently. We get a relationship that says two-phase designs, especially RCIs, with U-turn crossovers lead to more safety, and that's signalized or unsignalized. Yeah, the emotions of the drivers, we can't really get into their heads. I don't know, if they're being more negligent, maybe they are even being more negligent, but it is not being manifest in the crashes.
Awesome. Well, thank you guys so much. Great presentation. And we'll go ahead. Joe Milazzo, if you're here, we'll get you teed up and we'll go ahead and do your bio while you're getting your screen ready. Joe Milazzo is joining us from the Regional Transportation Alliance. He is going to share with us today about creating a new permitted phase opportunity and introducing the dynamic left turn intersection. Joe directs the regional business community's leadership and advocacy efforts on transportation issues, policy, and strategy. His primary role is to bring the business community together, leverage their strength, and accelerate success on key priorities for the growing Triangle region. Joe holds master's degrees in both business management and civil engineering from the NC State University and a bachelor's degree from Penn State. And he has been a licensed professional engineer in North Carolina for more than 20 years and a registered lobbyist in North Carolina for more than 15 years. So with that, Joe, go ahead and take it away.
That sounds great. Let me get this moving along. I don't know if you can see my screen properly or not. Can you see my screen?
Gotcha.
Okay, so right there. Well, thank you very much for the introduction. Thank you everybody for being a part of the Southern District meeting. And also, of course, thank you to the sponsors for this event, because that helps make these things a reality. So very much appreciate everyone sponsoring this meeting that we went over earlier. As she said, creating a permitted phase opportunity, or a new one in this case, introducing the dynamic left turn, and we'll just get right to it. So I want to acknowledge several folks who have helped out with not just the presentation, but really the whole concept and moving this forward over the past few years. One of which you just heard from in the previous presentation is Dr. Hummer with NCDOT. Also Kevin Lacey, State Traffic Engineer for DOT. David Spencer with the Town of Cary. Andrew Top with VHB doing some work for us. Dr. Chapman with Ramey Kemp also doing some work for us on analysis. Natalie Ridout, my colleague with RTA. So all of those and many others were part of this, but that's just a partial list in terms of on the presentation. So quickly about RTA before we talk about the permitted phase opportunity itself. So let me go to that. Let's go back up one step. RTA's role or mission is to deliver business leadership to get our region moving faster. And for those who don't know the market, we are in the Research Triangle region of North Carolina. Our group was founded by the Raleigh, Durham, Cary, and Chapel Hill Carrboro Chambers of Commerce about 20 years ago now. We represent more than 100 companies and 25 chambers of commerce. Our job is really from a business perspective, since we are a private sector organization, to provide focus and to catalyze action on modes of transportation that are really important at the regional level, and you see those here. And you also see what our goal is really to try to provide or combine a regional business perspective with a transportation focus to get results. And the true strategic results we're looking for are mobility and prosperity for our region. And we seek to do that year after year. And just as we thank some of the sponsors for the meeting today, I do want to thank, of course, many of the members of the organization, some of which are on in this call or this session, and others are part of the broader Southern District meeting. But of course, if you look at the membership of RTA, you can see several companies that are probably not normally on NICSide meetings, but they're great members, great partners for the business community, and are very focused on not just transportation per se, but for what effective mobility transportation infrastructure improvements can do for the community. And you can see a number of those companies here and organizations. But we thank all of them. So getting into more of the technical perspective, this presentation really focuses on dual left turn lanes at signalized intersections. So these are at traffic signals at signalized intersections, and particularly at dual left turn lanes. As Kristina mentioned, the opportunity for a permitted phase opportunity at certain locations. And when we talk about permitted, there's obviously benefits of that, but frankly, protected is the normal case for those, and you've seen those. That's a typical condition. And there's a lot of benefits of protected left turns. So let's be real clear about that. No conflicts, or more precisely, no conflicts with opposing traffic when you're executing the left turn. Another one is providing clear direction to the motorist. The arrow provides very clear indication of what the motorist is supposed to do, what protected or exclusive use is available to them. And it also can be more efficient because vehicles will then platoon together as they wait for that phase to come around in the cycle. So a number of benefits. Those are probably the more obvious ones. But we're looking for a permitted phase opportunity. And so we want to talk about some of the other, let's say, impacts of when you have protected only left turn. So specifically on that. And a lot of those are operational. So one would be it does require a dedicated phase for even a single left turning vehicle. Without any permitted phase available, then you have to display the dual arrows for that. And of course, while you're doing that, everybody else has to wait. And actually, Dr. Hummer and Amir both essentially talked about, some of the benefits of reducing the number of phases for efficiency and so on. This applies broadly. As a result of that, delays in travel times will increase, in some cases at the margin, by several minutes for some users, right? And that's for if you've just missed the arrow phase or that protected or exclusive phase, you're going to have to wait the whole way around the cycle again for that. And so, but if there were a permitted phase, then you would not. So those vehicles have, of course, the largest ones. The average delays are not near as much in terms of but there's still obviously more delays, and it's intuitive. Cycle lengths go up. You just saw the time space diagram, for example, for even three-phase signals. But of course, the more phases that you have, the more challenging it can be for coordination. And another one is potential maintenance issues. As you have fewer phases, and of course, in the most ideal case, other than no phases, or excuse me, one phase without a traffic signal, but when you get down to two or fewer phases, then the impacts of maintenance or situations that come up are less severe for the traveling public. But when you have multiple phases, and anytime loop detector or whatever fails, then you can easily be showing a phase to no one, which is dreaded, of course. And so we go on here. And so the dynamic left turn, which is a phrase coined by NCDOT, the goal there is to create a permitted phase opportunity for movements with two left turn lanes at signalized intersections. That's the objective there. Can we create a permitted phase? And you might say, well, there's other ways of doing that, such as just simply flashing the arrow for both those, and that's right. And in fact, dual left, flashing yellow arrow, or dynamic left turn, which is the new one we're introducing today, and have really the identical goal, which is to create a permitted phase opportunity for vehicles to go without, at times during the cycle, without the exclusive arrow. So what is the DLTI? What is that dynamic left turn? Well, from the implementation standpoint, what it is you close the rightmost or the outer, depending on how you want to think about it, left turn lane during periods when the permitted flashing yellow arrow is on or active. I keep going there. Apologize about that. So you can see it there. I'll show another graphic there, but in this case, the rightmost left turn lane is not available for use. The leftmost left turn lane is available, and then the flashing arrow would be available. There will still be a protected phase, or at least there could be. Operationally, it's not required. And so, again, when we think about the phrase dynamic left turn, which is, I think, a great way of describing this, dynamic means changing, of course. And when you're changing, of course, it's by time of day. So during peak periods, it's really no different than what we're used to. Both left turn lanes are open. Operation is protected only or exclusive only, what have you. During off-peak periods, the inner or the leftmost left turn lane is open under protected, permitted, or just permitted, depending on the cross products or what have you, and the policy of the agency, while the outer or rightmost left turn lane would be closed to traffic. And you can see, if you look at that graphic on the left, 2 arrows, peak periods, both lanes open, protected only. The rightmost graphic, X'd out the rightmost lane, the left lane remains open. The left lane, in essence, is the primary lane, which, of course, for those of us who are familiar with the phrase positive offset left turns, that's the one that's available. And, of course, the flashing yellow arrow would appear. So what are the use cases? When would you consider a dynamic left turn where you're closing one of the lanes during off-peak period? Our sense of it is there's really 2. One is when you do have adequate sight distance for the leftmost left turn lane, and that rightmost left turn lane maybe is marginal. Another one would be if you have some concerns about adjacent turning vehicles encroaching on each other while executing permitted dual left turns, for whatever reasons. From a policy standpoint, site-specific concerns, what have you. Some concerns about swept path issues. Either one of those would be a use case where you might consider this. But again, the dynamic left turn isn't appropriate everywhere, just like a dual left flashing yellow arrow. It's not appropriate there. So let's do a little comparison. So dual left, which we've seen in a few places, both in North Carolina and other places, where both left turn lanes are available, either under protected only or protected permitted. The use cases for those is more of an and gate, if you will. You have to have adequate sight distance for both left turn lanes and comfortable about that. And you also have to have no significant concerns about swept path issues or about adjacent turning vehicles encroaching on each other. In terms of the operational comparison, from the peak period, there's really no difference between either one of those. As you'll see, both left turn lanes would be open, protected only, and that's true whether it's dual left or dynamic, and I'm going to show that again. During off-peak for dual left, both left lane turn lanes are open, protected, permitted. And just like, excuse me, before I go out there, off-peak for the dynamic or the DLTI, only one is open. That's the difference. So again, the dynamic is both the time of day and the number of lanes. Here's how you sign and signal it, so to speak. A single 4-section left turn signal head mounted above the lane line between those 2 left turn lanes. And you can see that graphic there, 4-section head there. You also have lane use control signals at and in advance of intersection, at least for the rightmost left turn lane. You can make an argument to put them over both, even though the left one is unchanging. For the initial pilot, as you can see there, that is not the way it was done. It was just initially just that rightmost left turn lane, because that's the one lane that does change there. Here's a graphic. Again, see the DOT put this together. They did a very nice job with it. Again, you can see, obviously you see both left turn lanes. You see the 4-section head, the green arrow indicating the protected case. In this case, it would be protected only, of course, for the peak periods. For the off period, it would be the X is up, showing the rightmost left turn lane closed and the flashing arrow. You could probably realize at this point, there's nothing technically new here. These are standard devices. They're being applied, or it's the combination of this application that's new. It's more that approach or that combination. But there's nothing here that is new, and this is actually not an experimental design. So this has been piloted. And so NCDOT created some site selection criteria to try to select a location. They wanted some volume out there, obviously, and sufficient volume to justify having 2 left turn lanes, at least during peak, but enough variation during the day for left turning volume. So you would have opportunities to just have 1 left turn lane open. Adequate sight distance, in this case, for both left turn lanes. And the reason is, while really even marginal sight distance would be okay for that rightmost under long-term application, for the initial pilot, to make sure that this was working, they wanted to feel comfortable about the sight distance. And obviously receptive partners, which you need for any pilot for any time. The initial pilot was implemented in Cary, which is just outside of Raleigh. in Wake County, North Carolina, at the corner of what's called Tryon Road and Cary Parkway. It's been installed actually well over a year now, and it actually installed a little bit before the pandemic. Here's the location. Standard 2 left turn lanes there, you can see it. You can also see the cross-hatching there, which is designed to guide traffic to the primary or leftmost or positive offset, pick your favorite, guide them into that lane. I try to do that. There's another view on the back side. You can still see that same striping pattern. You can also see a line to help separate traffic through the intersection and also to guide traffic. So how's it done? Pretty well. It's been open in the town for more than a year, as I've mentioned. The operational framework has varied as pandemic and the travel has evolved as well. For several months, there really wasn't much dynamic happened. It operated as a purely positive offset left turn, where the rightmost left turn lane is closed, because there really wasn't a need to actually have the peak periods open. But then the PM peak returned, and then the AM peak returned. Some drivers are saving up to 2 minutes per travel time each cycle. With VHB do an estimate of travel time savings and using the typical assumed value of time, it actually paid for itself within 6 months. So that would, though we've not asked them to do it again, I would suspect it's paid for itself twice now at this point, based on that assumed value. Compliance is a good question. It just turns out at this particular pilot site, there's a shopping center just beyond the intersection for folks making that left and then turning into the right. So a little more than half the people prior to the pilot were actually in that rightmost left turn lane to try to line themselves up, at least at the margin. Some folks doing that. Well, it's worked pretty good. 85% are actually using the leftmost left turn lane. So we're getting better compliance. It is not 100% because it's still an unfamiliar piece, but as Dr. Amir and I both noted, it's a change from 65 to 15% usage of that rightmost left turn lane, which is good. Very limited citations through the first months of the pilot. I think that has largely been the case going forward up to this point. Definitely some lessons learned. You've got to clearly convey the expected benefit for the public because this is new. There was some question, it still comes up, well, why don't you just have both left turn lanes open? And you've got to try to describe what the use case is and why you're doing what you're doing. And the gist of it is in one sentence, so we can allow the flashing yellow arrow to appear. So you have to explain that. You have to add, we don't have to, but in this case, a sign was added to explain what the X is. You can see that there. It may be possible in the future to have the leftmost left turn lane not be a static sign, but also a lane use control, which might provide some contrast, and that sign may not be needed. We'll see on future installations. A little bit of striping was added in the intersection for guidance, and you do have to monitor some concerns about being trapped in the left turn lane for folks who are unfamiliar and who at other times of the day were used to using both left turn lanes and all of a sudden they can't. And so that's the nature of any pilot or anything new, but it's a legitimate concern. In terms of costs, not expensive overall. Dynamic left turn, 20 to 35,000, including that span wire in advance, lane control signals. Of course, the dual flashing yellow arrow is even lower and does not require that. So again, being very clear, if your dual flashing yellow arrow works, that's what you should use. You shouldn't use this dynamic left turn if the use case works for that, because this is a little more expensive. But either would typically make a competitive submittal for DOT for some of the new opportunities for funding projects in terms of spot mobility, what's called there in North Carolina. Where would you not do this? 3 or more posing through lanes, probably not. If you have inadequate sight distance all day for 1 or more of the left turn lanes, probably not. Same thing. So what's the current status? The department does consider this site a successful pilot. We're excited about that. We've held that final comparative analysis in abeyance, so to speak, due to the pandemic as it was installed just before that, and traffic volumes have yet to return to those numbers, at least in Cary. The department is sharing information with ITE and RTA. We're sharing with you all right now, other states. It is eligible for implementation of the locations in North Carolina. So we're happy about that. Again, that's a final look-see at that. Again, there's the title slide, which is always nice to have. Here's my contact information. And again, I work for RTA, which is the voice of the business community on transportation in the Research Triangle area of North Carolina. So I will pause there.
Awesome.
And happy to take any questions. And I also appreciate everyone's time today. And also, I certainly want a special thanks to all of our RTA members, current and future. Thank you.
Thank you, Joe. We actually have a couple of questions for you if you've got a few more minutes to hang with us.
Absolutely.
First question, is there any concern with having only one signal head for 2 left turn lanes came through?
Yeah, that's a fair question, and that actually came up during the initial analysis. So actually, the initial preparation for this. We had actually thought about, is there a way to do just one signal head and darken the other one? And that was not the answer. You had to go through this thing. My understanding, MUTCD, it's a should condition. It's not a shall for having one left turn lane and one signal head matching up with it. So it is reasonable to do that. And from a conspicuity standpoint, it's still right over the lane line. So not as much for that. Yeah, but fair question though.
Awesome. Another question here about how a signal transitions from displaying the dual left turns to a dynamic left turn.
That's also a great question. So there is a transition period, and when it goes from one to the other, and you do this even for other locations where you're switching lane use control signals, where you have that yellow instead of and then it goes to red and so on. And that actually what is displayed here from that standpoint. So the yellow and then it goes to red. It's not needed in the reverse direction, but it does come up for the one. But that's a fair question too. And Dr. Hummer is still on this call, so I would certainly welcome any additional thoughts or perspectives he could offer if he would choose to do so. No obligation, but he's first on the list, so I'd throw that out there. But that's how I would answer that.
All right.
Yeah.
Oh, Dr. Hummer?
Yep.
Yeah, I'd say, Joe, you're doing swell so far. Keep it up.
We actually have a couple more if you've still got some time.
Sure.
Question came in about whether or not both lanes are being utilized equally when they're open, or are drivers favoring the lane that's always open?
That's a fair question, and I don't remember that at the top of my head. I want to say it's decent utilization and fairly balanced, but I actually don't recall. It's a fair question on that. I could get it. Joe, do you happen to remember that answer or not?
I don't remember that one either. Whether it even reverts to being more traffic in the rightmost turn lane, because that was the sort of typical or previous pattern.
Yeah,
I'm not sure.
Yeah, my guess or recollection, such as it is that it's not as much as it originally was, because you're guiding some folks over there, but there's certainly people who are wanting to get in that lane, particularly when they're trying to make that turn into the shopping area. So, but we could certainly find that out, and we'll do a quick review of that and send that to you, Kristina.
Awesome. Thank you, guys.
Yeah. Any other questions?
I think that's all we've got. So if no one else has anything else, I'm not seeing anything pop in to our little chat here. But we'll go ahead and move on to John's story.
Sounds good. Thank you.
Thank you, Joe. John, if you want to go ahead and get your screen pulled up. Awesome. So John's
showing now?
We've got you. John's going to be with us today talking about TDOT's Highway System Access Manual. John is a senior transportation engineer and the Tennessee Planning Department lead with Gresham Smith. John has a bachelor's and master's degree in civil engineering from UT Knoxville. Go Vols. He is a registered professional traffic operations engineer and a member of ITE, and he is also a past president of the Middle Tennessee section of the American Society of Highway Engineers. In his free time, he enjoys cycling, hiking, and watching his daughter play softball, and whatever his 2 boys happen to be into at the time. He is passionate about autism awareness and advocacy. So with that, John, thank you for being here with us today, and we'll let you go ahead and take it away.
All right, thank you, and thanks for having me here to talk about the TDOT's new Highway System Access Manual. Before we jump in, I'm going to give a little bit of project history and purpose. So the Highway System Access Manual is a 3-volume set. Volume 1 is a planning document that covers land development regulations and corridor management agreement guidance. Volume 2 is what we're predominantly going to talk about here today, which is the intersection and interchange evaluation process that TDOT is starting up. And then, we will close with Volume 3, which is roadway design guidance. The guidance is new. It was just uploaded to the TDOT's website in January as far as the planning and intersection and interchange evaluation manuals. And the volume 3 manual is in current review. We've submitted our second draft this morning, and so that should be uploaded here fairly soon to TDOT's website. It was about a year-long process. We had a notice to proceed in February of 2020. And splashed on the screen is the website for where the volumes can be downloaded, the ones that are already posted. You know, it's a pretty long link there. You can also just search TDOT Highway System Access Manual. It'll pull up. So when we got started on the manual, we knew that if we received our notice to proceed and just sort of disappeared for a year, that it would be would not be a success. So we, with TDOT's agreement, set up a working group organization. And so we had different teams from within TDOT on each of the 3 volumes. And of course, we met at regular intervals and really made sure that this was TDOT's guidance and not just sort of, you know, taking TRB's guidance and putting it into a TDOT template. But we really had the TDOT folks involved the whole way through to develop the guidance. So when you going in, everyone knew that this was going to be a controversial subject. Access management always is. So if you would just bear with me for a minute, we talk about, you know, why TDOT decided to take this on. And it really came down to safety and capacity. So with good access management, there's plenty of guidance out there that you can reduce crashes 20 to 60%. And that's pretty significant considering that about 55% of all vehicular crashes involve some sort of access activity. And in Tennessee, if you do the, you know, play the numbers, that equals around 300 access and 60 driveway related crashes a day. So you can get a significant amount of safety improvement with some good access management standards. As far as capacity, plenty of studies out there, you know, 40 to 60% reduction in delay with good access management. And as you know, all of us are pretty familiar with the transportation and land use cycle. You know, you can start anywhere on the cycle, but in general, you know, let's just say we start with arterial improvements, where TDOT would come through and improve a arterial. That would, of course, increase accessibility to the area. That increases the land availability, which generally leads to increased land value, land use change. As the land is developed and the traffic increases, level of service goes down, and then there's calls to improve the highway again. So the goal with improved access management standards was to slow down that cycle without slowing down any economic activity. The chart that just slid on the screen is really one of my favorite as far as explaining good access management. This takes a baseline. This is from TRB, and they studied hundreds of corridors. And if you take 10 access points per mile as your baseline, then by the time you get to 20 access points per mile, you've got about a 30% increase in crashes. And then, of course, by the time you get to 40 access points per mile, you've doubled the number of crashes along the corridor. So very clear link to access points per mile and crashes. And then as far as operations, if you look at a 90-second cycle length, which is a pretty common signal cycle, if you have a signalized intersection every half mile, you can get about a 40 mile per hour progression speed. If you drop that down to 1/8 of a mile, you're really only going to get about 10 miles per hour. Now, you know, we worked closely with the multimodal division in here, and in fact, Gresham Smith had previously worked on TDOT's multimodal design guidance. So we were, you know, very cognizant that you don't always want to have those 40 mile an hour progression speeds, but certainly in some land use areas you do in your rural and more, less dense areas. But we did take into account multimodal concerns as we developed the updated access management standards, and I'll touch on that here in a little bit. But of course, we always hear as we got going, well, we can't harm business. We can't put people out of business with improved access management. And so on the screen is really what we hope to demonstrate is that we really want to get the same or more amount of economic development and activity out of the same space, but with fewer access points on the arterial. So the top picture on the right shows what unfortunately is a pretty common development pattern in Tennessee, where each commercial development gets their 2, sometimes 3 driveways, and you wind up, you've got 6 driveways there along the arterial, and then 1 access point off a side road. The slide to the bottom shows what, in a perfect world, we'd really like to see more of, and that's where you can condense those access points to maybe 1 along the arterial, a couple of access points along the collectors or local roads that come off the arterial, and have the same or more amount of economic activity and probably higher land use values based on the development pattern as you do up top, but with the improved operations and safety along the arterial. All right, so moving on from sort of the why TDOT decided to take this on is the Volume 1 planning. So the planning volume provides guidance on how to develop corridor management agreements. It also has some model land development regulations, and it's different than the other 2 volumes in that it's not guidance as much as it is a resource. It's for local agencies to use to help them with their land development regulations and to develop corridor management agreements should they choose to do so. For those that aren't familiar with what a corridor management agreement is it's a collaborative agreement among multiple jurisdictions or agencies that address the development, management, and operations of a transportation corridor. So it's not just a traffic study. It really takes a holistic view of a corridor that maybe runs through 2 or 3 towns or a couple of counties, and works with a team that has buy-in of local officials, both elected and your planning and engineering staff, to come up with a vision for the corridor so that it maintains a consistent operational characteristics throughout the corridor. TDOT's been doing them since 2010, but they really had not, up until now, had been sort of an ad hoc development, and they realized they really needed some written guidance and a manual on how to develop proper corridor management agreements. So that was what about half of the Volume 1 is about, is the corridor management agreements. The second half is about model land development regulations. And so TDOT, by law, does not get into land development laws. That's for local governments and agencies in Tennessee. But of course, we, as all traffic engineers know, you're really fighting with one hand tied behind your back if you can't address land development when you're making traffic decisions. So TDOT wanted to develop these model land development regulations that could be a resource for local officials that wanted to make what we believe is better land development decisions. It is geared towards more rural counties and smaller cities. Your larger cities that already have an established planning department and land development regulations, quite honestly, will probably find it of limited benefit. But there's a whole lot of counties and small towns in Tennessee that don't have planning staff. And so this serves as sort of a tool for them to help to get to those development patterns that would really help the transportation network, such as what we're seeing on the screen here, where the arterial is really serving the through traffic, and then the access to the developments is coming off of the local and collector roadway network. So there's 25 different main topics of land development regulations, and it's basically plug and chug language, you know, where we have blanks where people can just kind of switch out some terminology, but and make the regulations their own. But covers about, well, 25 different topics, and I've got a handful of examples here on the following slides with some images to help demonstrate sort of what we're talking about. So one is joint use driveways and cross access. You know, instead of every parcel receiving a driveway on the arterial, it's the regulatory framework to get those properties to share access, and also how to phase out you know, existing driveways as their neighboring parcels are developed. And that way you can go from 4 driveways to 2, as shown here, with the joint use driveways and cross access for that commercial development. There's also some regulation language for promoting reverse frontage, so that your developments are being accessed off a collector road behind the developments, instead of every parcel having a driveway on the arterial. There's model land development regulations for out parcels, which is kind of similar deal, but you know, so that those out parcels are getting their access from internal circulation of the development instead of off of the main roadway network. And then something we especially see in rural counties are, you know, where maybe it's a farm or a large parcel that gets developed into a rural subdivision type development, where you have, you know, 10 100-foot wide parcels that go back, you know, several hundred feet, and each one gets a driveway because by law they have to have access. But it's how to help promote more of the development pattern seen in the bottom of the image, where you're really reducing the number of access points on the arterial, but still fitting in the same number of homes. So that's a very quick review of the Volume 1 planning. Now, Volume 2 is where we discuss intersection and interchange evaluations for TDOT. And this is really to help promote more innovative intersection and interchange design options. So it is a documented screening process for intersection and interchange selection. It takes into account traffic, operation, safety, and life cycle costs, and it allows flexibility for local conditions. As you'll see as we get into this, that there was very firm direction given from our working group that TDOT did not want a rigid system that, you know, if something came up #1 in the ranking, that was what would have to be constructed at the site. It was, this is very much a, just provides good guidance and framework for good traffic engineering. So for TDOT, it is branded as intersection and interchange evaluation. For many on the webinar here, you might know it as FHWA's ICE process in policy. It's really the same process that we use. TDOT just wanted a little different naming and branding on it. But this will put TDOT in one of the, you know, front third of states that are really embracing the ICE policies that FHWA has been promoting for a few years here now. A document that was very handy as we developed this was FHWA's Alternative Intersections Interchanges Informational Report. These are a lot of the type of intersections and interchanges that TDOT want to, you know, make sure we're getting considered. Again, it doesn't mean they're getting selected, but at least getting considered and not forgotten about as TDOT goes through their intersection interchange evaluations. So on the screen are the list of the intersection types that are included. Of course, roundabouts, I hesitate to really call them innovative anymore, but certainly wanted to make sure that they got considered. And then TDOT also here recently has had a pretty good push on J-turns, which are, just unsignalized R cuts. And then certainly any of the other innovative intersections also to make sure that, sort of no stone is going unturned, that everything's being considered as they make decisions on intersection control. And then on interchange controls, again, I won't read the list there, but the point was, again, just to make sure that the new innovative intersection or interchange control types are being considered. The guidance does really, it has to do with service interchanges. There's not a lot of, there's not anything in here on system to system interchanges, but of course those usually aren't a matter of access control because those are, two interstates coming together generally, or fully controlled access state routes. So TDOT's IIE process is implemented in two stages, similar to the FHWA ICE process, where stage 1 scoping and stage 2 preferred option selection. And honestly, stage 1 scoping is really what's sort of new to TDOT. Once you get to stage 2, which is preferred option selection, that's really, a lot of what TDOT does now. So the stage 1 scoping is a step to determine the short list of all possible options that merit further consideration and analysis because they meet project needs and are practical to pursue. So it's a very a quick, almost checklist type of process to very quickly get you to stage 2. And then stage 2 is, of course, is the more detailed, where you're doing your more traditional preliminary engineering, more detailed traffic analysis, cost estimating, that sort of thing. As part of the project, we developed several forms that are really sort of the backbone of the intersection and interchange evaluation process. The first form is a general traffic engineering data that's needed for the analysis. This is data that TDOT generally already collected for any of their scoping type studies, but it gets it all in one form so that it's all there, helps with higher level staff to quickly see the information there as far as the existing traffic and data. So it's got an area for your existing and predicted and projected AADTs, along with truck percentages and things like that. It's got a qualitative checklist of things for multimodal activity. So we didn't want to just have a how many pedestrians are out there question, because if you've got a location now that has no sidewalks, of course you wouldn't have any pedestrians. So it's more questions, get people thinking about what the area will look like in the future, and what conditions are out there where people may want to walk. So things like, are there bus stops nearby? Is there a retail center nearby, school, library, those types of prompts to get people thinking about pedestrian needs. There's an area for crash history and intersection crash rate, so that you can see how a location compares to the statewide average rate on crashes. That of course may shift your selection process. If you've got a really high crash rate location, then maybe you want to put a little more emphasis on safety than just operations. So that's a main driver of why the crash history and rate information is included on the form. And then your existing and projected turning movement volumes. From there, you go to the stage 1 scoping form. And again, intended to be a very quick checklist of the different options to be considered. The first column you'll see there is a conflict point score. So we've taken, just to have a really quick and dirty safety assessment in this stage 1 scoping, taken a conflict point score approach. So this is uses really the information that are in your number of intersection conflict points, which has a lot to do with an intersection safety, except we do weigh right angle crashes and head-on crashes, those types of crashes that are likely to have a worse impact on the driver and passengers, we weigh them generally twice as much as the other types of conflicts. So you come up with a score that is rated where, the lower the better. So that's why, like, if you look down at a roundabout, it has such a low score because the crash potential that is there are generally sideswipe. So you're not going to get into those really bad right angle crashes there. And then from there, it's a series of yes, no questions. So, the first one is the option feasible and reasonable. So we trust these are filled out by engineers, maybe planners as well. But, just general knowledge of the area, is it reasonable to consider some of these options? And in some of them, they won't be. If you're thinking about a mini roundabout, you probably certainly aren't going to be considering an echelon intersection. So, so you just go through and quickly eliminate those that just aren't reasonable to consider. From there, you ask, is the option likely to improve or maintain safety? We would hope that the conflict point score would be beneficial in that decision, but it doesn't have to be. It can be judgment, just a quick yes or no answer. Then, is the option likely to improve operations? Again, just the general thought of how that would impact. We haven't done a detailed analysis to this point, although we have asked people to do a CapEx analysis, which I'll get to here in a second. And then, is the option likely to improve or maintain multimodal access? So if there's likely to be pedestrian activity, you probably want to stay away from some of these options, and the manual provides some guidance on that as far as which ones are better or worse. But like you likely wouldn't want a continuous green T where you have a movement that never stops if you have a lot of pedestrian activity you're trying to get across the street. Then the next two columns are for filling in CapEx. So CapEx I'll cover on the next slide, but it's an FHWA spreadsheet tool to quickly look at volume to capacity ratios to see if it looks like an option would work. And that would help then screen out some of these options that would not likely have the capacity needed for the location. And then from there, a simple, should the option proceed to stage 2, along with a very small, a short discussion of why or why not. So the manual discusses you really don't want to carry more than 2 or 3 options into stage 2 because that's where really the time and effort and money is spent to do the evaluations. But this just sort of gets folks quickly thinking about, well, hey, will some of these more innovative intersection and interchange designs work in a location? I mentioned that to help that is CapEx. So the manual provides guidance on how to download and use CapEx. For those not familiar, it's a really handy volume to capacity ratio spreadsheet tool that FHWA developed. It's now maintained by the Crash Modifications Clearinghouse. As we were developing the project, some states do take CapEx as a starting point and develop a state-specific spreadsheet. This is sort of TDOT's beginning into this effort, so they wanted to use as much available resources as possible. And so it was decided that CapEx was really a good starting point instead of diving in and developing a custom tool. Try out this first rollout with CapEx. Maybe there'll be some modifications in the future to make a TDOT specific tool, but for now, CapEx was selected. And again, this is certainly no replacement for CapEx is no replacement for detailed traffic analysis like HCS or Synchro or VISM, but it does give a very good tool for checking the volume versus capacity ratio and see if something's a reasonable alternative to consider. So after you've selected your 2 or 3, maybe even up to 4 options that you want to carry into stage 2 selection, Again, this is where you're going to spend some time and effort on your analysis. This is where you're going to be doing your more detailed traffic analysis. You are going to be developing construction cost estimate. Generally, TDOT has their own tools, but certainly any other state, just whatever tool you would use to develop your opinion of probable cost. We do provide an optional guidance for doing life cycle cost. It's not required in TDOT's process as of now. They'll try it out maybe on, more larger projects. They'll take a look at that. But there is guidance on how to do a life cycle cost analysis as part of this, the IIE. And then the traffic analysis, which would be very similar to what TDOT currently does in their option selection. We do have optional predictive crash analysis. So we provide guidance in the manual on using FHWA's SPICE tool, but certainly if it's a more detailed study, you could use IHSDM or any of the HSM spreadsheets, whatever, as long as the TDOT project manager agrees for doing the predictive crash analysis. And in fact, predictive crash analysis is optional, period. So in more simple locations, it may be bypassed altogether. Now, of course, if you do a life cycle cost, you have to do the predictive crash analysis because that gets fed into the life cycle cost. And then there's some prompts for multimodal considerations and stakeholder input. TDOT certainly wants to get the support and buy-in of local officials where these intersection and interchange is going to be constructed to make sure that they have the buy-in of local community as well. So as far as life cycle costs, this is a first implementation of formal life cycle cost for TDOT. TDOT has selected to use the life cycle cost estimate tool. It's from an NCHRP report. It's a free download. Again, a decision by TDOT to use as many available and already developed resources as possible. But we do provide guidance on how to use it. Some of the inputs that should be sort of standard inputs for TDOT use is provided in the manual, as well as information on where to download the tool and how to, just generally how to use it. And then for the predictive crash analysis, we specifically wanted to keep this as simple as possible. TDOT has been using predictive crash analysis, but quite frankly, IHSDM can be kind of a heavy lift. So sometimes it doesn't get used, even though everyone sees the benefit of it. So we wanted a very simple tool, and SPICE fit that tool. And that way maybe it would get used a little more often. SPICE is geared towards intersection controls. It can do some interchanges, but really, if you get into an interchange, you probably want to just switch gears and get into an IHSDM analysis. But SPICE, again, very simple tool developed by FHWA, maintained on the Crash Modifications Clearinghouse. We provide some guidance on how to use it for TDOT's process, and really hope that it takes hold and sees more use as far as predictive crash analysis in the process, because there's a lot of benefit to doing that. Okay, so that was the a summary of what all is in the intersection interchange evaluation. Before I stop, I will get just a very brief summary of the volume 3, which is design, which again, that draft went in this morning, the second draft. It'll be posted fairly soon on the website. But this is really the most controversial one, because this is the one where we get into updates for driveway spacing and median openings and, that sort of thing. So the Volume 3 does update TDOT's design criteria. It's very closely coordinated with the 2018 AASHTO Green Book to get TDOT's design guidance more in line with that, and as well as some other terminology. It implements some elements of TRB's Access Management Manual 2nd edition. Very importantly, we did a peer exchange with GDOT and VDOT and had some conversations with them on what they were doing that worked for them, and you know, what they would like to see changed if they could in their process. It was you know, very much on purpose. We wanted to have that peer exchange with our sister states that have sort of similar geography and political makeup as Tennessee, so that you know, we have sort of a consistent approach across these states, and certainly it was tailored to Tennessee as we went through the working group and everyone worked together on that. One of the big things that was driven into us as we got started was that TDOT leadership wanted to make sure that it aligned with the 2018 Green Book's context classification system. So TDOT guidance has been in agreement, of course, with the functional class of local, collector, arterial, and freeway, but we're still very much operating on just rural or urban, you know, as far as context classes in Tennessee. So this is the first design guidance for TDOT that switches over and does the rural town, suburban, urban, and urban core. And we're excited about it. It certainly is going to, I'm sure, be a little bit of a you know, rocky road as it gets implemented, because this is the first manual that's doing it. So some other areas kind of need to catch up as far as the official classification map of the routes and such. But this does get it started, and it really does give us a lot more options to help take into account pedestrians and bicyclists by having those extra context classes than just rural or urban. So some of the main points that we hit are intersection spacing, driveway spacing, median design, U-turn guidance, and turn lane warrants and length. And on turn lane warrants, you know, just to touch on it real quick, TDOT has been using the old Harmalink tables. I think have been around since the 60s. And so we're bringing them up to the newer NCHRP I forget the numbers now, but there's a couple of NCHRP reports on updating those unsignalized turn lane warrants and links that are also in the 2018 Green Book that we've utilized in TDOT's guidance. There's a whole suite of options as far as intersection and driveway spacing that are considered. And they really have a lot to do with, of course, functional and context classes, but also, you know, whether the arterial has a restricted median. So as folks are able to get a hold of the Volume 3 and take a look at it, you'll see that we allow a lot closer driveway and spacing when you do have a restricted intersection. So if you're looking at right-ins, right-outs, J-turns, we're you know, pretty comfortable with those being pretty closely spaced like they are now. But it's the full access locations that we're really trying to get spaced out. And that's because the safety data shows that those restricted crossings are so much safer that we can stand to have those a little closer. And then if we can try and space out the others, then all the better. When we got started on this manual, you know, we found that TDOT's spacing requirements are generally about half of the other states around them. So there was, you know, some room to get a little more restrictive in the guidance without sort of falling out of the norms of the area in the Southeast. As I said, we also coordinated closely with multimodal on this. You know, improved access management standards have a lot of multimodal opportunities. You know, we would love to see more medians as part of our access management standards, and those medians can serve as pedestrian refuges. And in fact, TDOT has specifically requested that the medians all be wide enough to accommodate pedestrians. You know, the 6 foot instead of the old 4 foot, just in case, even if it's not intended to serve as a pedestrian refuge, so that it can. Then fewer driveways or fewer conflicts with pedestrians and cyclists, and improved opportunities for transit operations, just because you know, an arterial that functions more consistently can provide those more consistent headways for transit use. But we certainly understand that there are challenges with access management standards when it comes to multimodal, and that's that, you know, sometimes it does, the access management standards do promote more and larger turn lanes and radiuses, and those can lead to some safety concerns for pedestrians and bicyclists. And then also larger intersection spacing creates fewer crossing opportunities and potential for higher speeds for motorists. So this is really where those additional context classes came in handy, because as we got into the more suburban and rural areas, you know, maybe you do have a little more emphasis on the motor vehicles and their throughput and safety. And then in your urban core and more dense suburban areas, rural towns, you certainly want to start thinking more and more about those pedestrians and bicyclists. All right, that was you know, the 3 volumes of the TDOT's new Highway System Access Manual. Certainly happy to answer any questions that anyone might have. And Kristina, I can't hear you if you're talking.
All right, looks like Kristina may have lost her ability to speak in the mic. I don't see any questions come in. I'll kind of jump in and take over at the end. Does anyone have any questions for John? All right. If not, then I'd like to give another thanks to our session sponsor, Urban Systems. And the next session we have coming up is at 3:30, I believe. And that'll be concurrent sessions as well, so you can choose which one you want to go to. If that's it, then everyone, thanks for joining. Thanks for our panel, our speakers. Appreciate your time and effort.